This tutorial is all about yield in chemical reactions, and yield is a comparison of the amount that we actually get of the product compared with the amount that we might expect or predict for product based upon how much reactant we've used. You have to learn this equation here. Percentage yield equals actual yield divided by predicted yield times 100%. This will not be given to you on your exam paper. You'll be expected to be able to do calculations based on that, and at a high level to explain why industrial processes want as high a yield as possible. And there are 2 points that you need to learn from the specification here. There's all sorts of reasons why we never get 100% yield in a chemical process. For example, some reactions don't actually go to 100% completion, but they end up at an equilibrium point where there's some reactants and some products in the mixture at the end. But whenever we're trying to make something, we lose some of the product when it's poured from container to container. Some gets lost in filtration by soaking into the filter paper. Others might evaporate or get lost in other ways. So the amount we do end up with is called the actual yield. It's the mass of the product that's isolated and weighed at the end of the process. And this compares with the predicted yield, and that's the amount of product that you could theoretically get based upon how much reactant you started with. The percentage yield, as we said, is the actual yield divided by the predicted yield multiplied by 100%. In industry, they like to have a high percentage yield. This is one of the jobs of a chemical engineer, to try and make the process as efficient as possible, because having a high percentage yield means that very little of the reactants are wasted, and that will reduce costs for the industrial process. Now, the calculations are straightforward so long as you get the predicted yield and the actual yield the right way round. Let's have a look at some examples. Paul reacts some potassium hydroxide, KOH, solution with some nitric acid, HNO3. Potassium nitrate, KNO3 and water are formed. Write a balance symbol equation for this reaction. Well, the reactants are the things we start off with, which are the KOH and the HNO3. The products after the arrow are the KNO3, and the water, which you have to know, gosh, I hope you do know, is H2O. And then we look to see whether it is balanced, because we're asked for a balance symbol equation. So 1K on each side, 1, 2, 3, 4 O's, 1, 2, 3, 4 O's, 2 H's, 2 H's, 1 N, 1 N. So yes, it balances. Next part, Paul expects to make 6 grams of potassium nitrate. He actually makes 4.8, so calculate his percentage yield. Usually you're given 1 mark in case you don't get the correct answer, 1 mark for the correct equation. So we'll write down percentage yield equals actual yield divided by predicted yield times 100%. Nicely, they've put these in the right terms. Expected is sort of predicted, so that's going to go on the bottom. The actual is the 4.8, so that's going to be 4.8 grams over 6.0 grams times 100%, and this comes to 0.8 times 100%, which is 80%. And another similar one, Ryan makes some ammonium nitrate. He predicts to make 25 grams. His actual is 20 grams. Calculate his percentage yield. Here, percentage yield equals actual yield over predicted yield times 100% equals 20 grams divided by 25 grams times 100%, and that comes to 0.80 times 100%, which is 80%. And the last one, just to show how easy these are and how similar they are from year to year. Percentage yield here, percentage yield equals actual yield over predicted yield times 100%, which in this case is going to be 6.0 grams over 8.0 grams times 100%, which in this case is 0.75 times 100%, or 75%.